Now let us see about the composites, right? So here we can understand the introduction to these composite materials, right? The properties and application of these composite materials, and then after understanding all those things now and then we can go and understand about carbon fiber reinforced polymer composites as well as metal matrix polymer composite, right? Metal matrix composites, right? So coming to this word composites, how one can define this? So what do you mean by composite, right? So usually the composite materials are first developed for military and aerospace application in the year 1940s, right? In the year 1940s, especially the polymer composites, right? So especially the polymer composites. Okay, see the composites, right? It is a combination, as the name implies, it is a combination of two or more distinct components in order to form a new class of materials which are suitable for structural applications. They are called as composite materials, right? So composites is a combination of two or more new materials in order to generate, right, a new class of materials which are which are suitable for structural applications, right? So if one of the component is a polymer, then it is called as a polymer composite, right? So then one can call it as a polymer composite like that. If one of the component is I will tell about classification later. So coming to the composition of these composites, right? So usually composites consisting of two components. The one is a matrix, the other one is a matrix, the other one is a fiber, right? So matrix is usually a thermoset polymer material, right? So which is capable of embedding, encapsulating, reinforcing or adhering, right? So it gives stability and strength to the composite materials, right? And it will define the salient chemical, mechanical, electrical and physical properties of that composites. This only will decide, right? And if you can look at the examples, so you can take an example of epoxy resin, right? Epoxy resin, polyester, phenolic resins, bakelite, so etc. can be used as a matrix in the synthesis of a composite, right? So it is a combination of two or more distinct components in order to form a new class of materials which are suitable for structural applications. So coming to this fiber, the second component in this composite, fiber is any fibrous materials which give network structure to this matrix, right? Which will give network structure to this matrix, right? So if you see the examples for these fibers, usually the most commonly used fiber will be glass, and sometimes people are using Kevlar fiber and carbon fiber, right? Kevlar fiber and carbon fiber, right? So this is the thing, usually these fibers will be embedded or reinforced into the matrix, thereby in order to make matrix stronger, right? This will make matrix very, very stronger. These are the examples, right? So if you look at these composite materials, the main feature of this composite material lies in the fact that they are lightweight, right? They are lightweight and they are very, very strong, right? See, they are strong, they are often stronger than steel, but weight is very much less, right? So this is the reason why people are going to use these composite materials in the manufacturing of so many aerospace applications and in automobile applications in order to make automobiles lighter, thus thereby achieving higher fuel efficiency, right? So this is some introduction about these composite concepts, right? Composite materials, right? So if you come and see the classification or types of these composite materials, we can classify these composites into three important types based on the matrix used. We can classify composites into three major types. types of composites, right? So the first type is, here I will write, the first type is ceramic. First type is ceramic matrix composites. This is one of the type. The second one is polymer matrix composites. Polymer matrix composites. Right, and the third type is metal matrix composites. Metal matrix composites. Remember, right? Polymer composites, polymer metal matrix composites, ceramic matrix composites, and metal matrix composites, right? So these ceramic matrix composites can be further classified into two types. One is short fiber composites, right? Short fiber composites, and this is long fiber composites or continuous fiber composites. Right, these polymer matrix composites can be classified into thermosets. See, this is important, thermosets and thermoplastics. Right, thermosets and thermoplastics, right? So they are further classified into three types. One is glass fiber composites, right? Glass fiber composites. Here it is organic fiber composites, and third one is carbon fiber composites, right? We can write this carbon fiber to this side. So carbon fiber, right? Carbon fiber composites. This is glass fiber composites. Remember, glass fiber composites, right? So this metal matrix composites can be further classified into three types. So one is particles reinforced, short fibers reinforced, and the plates reinforced, right? Particles reinforced, right? Particles reinforced, and then plates reinforced, so reinforced, and then whiskers reinforced, whiskers reinforced. Remember, so like this one can classify the composites, right? Composites are a combination of two or more distinct components in order to form a new class of materials which are suitable for structural applications, right? So once a composite is formed, it is going to exhibit excellent properties compared to this matrix alone as well as fiber alone. So this is the beauty of these composite materials. Coming to this, so if you can see the fibers, here I have given the example for polymer composites. The fibers are used glass, Kevlar and carbon fiber. If you can see for ceramic matrix composites and polymer matrix metal matrix composites, see the different types of reinforcements they are used, right? And they are called as, right, different types of reinforcements that is used in place of fibers, and they can be classified reinforcements that are used in the manufacturing of composites are, so there are four major types of reinforcements are there. First one is particles, right? Second one is short fibers, short fibers. The third one is continuous fibers. Continuous fibers or fabric materials. And fourth one is plates or sheets. Plates or sheets. Okay, plates or sheets. So like particles means they will be looking like this. Okay, if we can just, I will give a picture representation like this. These particles will be looking like this. Okay, short fibers means you need to take a short fibers of this size and shape. Okay, so like this it will be there. Okay, and continuous fibers means we can write like this. It will be like continuous from the other side also, opposite side, continuous to the opposite side also, right? So like this. So coming to plates and sheets, so that if you can write like this, they will be arranged in the form of sheets or plates like this. Okay, so these are all called as various reinforcements that are used in composites, right? So remember, so if you can see the properties, general properties, I am not restricting this to only polymer matrix composites or ceramic matrix composites or metal matrix composites. In general, if you can see, they are very strong, but weight is very much less, right? They exhibit high stiffness, very strong, very high impact strength, tensile strength, everything will be there. The one of the very important feature of these composite materials is their high strength to weight ratio. This is important. High strength to weight ratio, right? So that's why I told that they are often stronger than steel, but weight is much less than that, right? So that is a thing. So just like that, any other polymers, these composite materials are resistance to chemicals, resistance to corrosion, wear, tear, impact resistance, and then resistance to heat, fires, etc. So they exhibit low distortion properties, high excellent creep resistance, right? So like that, low density, that is light in weight, right? So these are all the different properties of these composite materials in general, if you want to list. So coming to the general applications, right? If you can list out the applications of these composite materials in general, right? So you can list out so that they can be used, right? Here I will write, right? They can be used in so many advanced fields, right? In so many advanced fields, such as like they can be used in infrastructure applications, right? For the construction of buildings, bridges, right? Roads construction, right? Highway construction, flyover construction, there also they can be used. That is one thing. They can be used in thermal engine and blades. They can be used in automobiles, aerospace industries. They can be used in the manufacture of rockets, missiles, satellites, right? And they are also used in electronics, right? And in the packaging of things, right? And then in biomedical applications, right? In missiles, military applications, there and all, these polymer composites or composite materials can be used, right? So this is all about the general introduction about the composites and the components of this composite. That is, one is matrix, the other one is fiber. These are the different types of reinforcement, because usually these fibers only reinforced into the matrix in order to make matrix stronger, right? But its chemical, physical, mechanical and thermal characteristics will be decided by this matrix, right? Based on the matrix, we can classify these composites into three types: ceramic matrix composites, polymer matrix composites and metal matrix composites. So based on the reinforcement used, they can be further classified into sharp fiber composites, long fiber composites, thermosets and thermoplastics, right? Carbon fiber composites, this is carbon fiber composites, right? Organic fiber composites and glass fiber composites. See, under polymer matrix composites, we have already discussed about Kevlar fiber composites. So now in this session, let us after completing this concept, let us take a carbon fiber reinforced polymer composites and let us discuss. Coming to and then metal matrix composites. In metal matrix composites, based on this reinforcement, they can be classified into particles reinforced, plates reinforced, and viscous reinforced. Right. So based on the knowledge of composites, now let us understand these carbon fiber reinforced polymer composites or carbon based composites, reinforced composites, right? So carbon fiber reinforced composites, right? Polymer composites. In short, they are called as carbon based composites, right? That you can call it as carbon based or CF or P, carbon fiber reinforced polymer composites, right? See, they are advanced polymer composites or they are advanced composites. So, and they are of very much use. So why? Because they show great versatility. This carbon fiber based polymer composites shows great versatility. So why? Because versatility. Why? Because the presence of carbon atoms, right? So they enable them to chemically bonded with any of the other carbon based materials and with a wide variety of different elements in order to form very strong covalent bonds, right? Based on the presence of carbon atoms, right? So that's why it makes carbon based fibers more versatile than any other fibers, right? So as a result of which, so these carbon based materials start to exhibit excellent properties, like they exhibit high strength, high flexibility, right, high density, and then high hardness, right? So if you can look at the carbon based fibers, they weighs around of about 25 percentage. They weighs about 25 percentage less compared to steel, and they weigh 70% less compared to aluminum. Just imagine, right? This carbon based fiber reinforced material weighs 25% less than steel and 70% less than aluminum, but they are equally stronger than these two metals by weight, right? So that's why their high strength to weight ratio is a very important aspect of any of the composite materials, right? So this is the thing. So if you look at the properties with this introduction, if you look at the properties of carbon based fiber composites, carbon based composites in general, I can call like this. So you can list out so many properties like this, right? So they are going to exhibit high strength, high stiffness, hardness, toughness, right? And they can exhibit high load bearing capacity, right? See all these things, etc. And then lightness, right? And high damage tolerance, low damage tolerance, so low friction coefficient, and then good wear, tear, chemical, corrosion resistance, heat resistance, fire resistance, right? Excellent creep resistance, right? Creep resistance. All these things are the very important properties of these carbon fiber reinforced polymer composites, right? So you can list out like this. So high load bearing capacity, low density, they are very stronger, but weight is much lesser than that of these metals, as I said, right? And then high toughness, right? High strength. So in this series you can give high toughness, right? Highly rigid, high hardness, it is very light, that is lightness. Low density it is called as, right? So coming to the next point, it has a low damage tolerance, right? Low damage tolerance, and then it exhibit excellent wear resistance, wear, tear, chemical, right, corrosion, fire, heat and resistance, right, and it exhibits excellent creep resistance also, right, creep resistance also. So the low friction coefficient, that also you can list out, low friction coefficient, right. So etc. makes these carbon based composites are more versatile, right. And coming to the applications, so general applications I already told. These composite materials found applications in the advanced fields such as in the construction areas, in the thermal engine and blade, in automobiles, in aeroscraft, in military, rockets, missiles, satellites, in electronic fields, and in biomedical fields, and in packaging fields, etc. So if you go more specifically with respect to this carbon fiber reinforced polymers, right, so you can list some of the applications. They can be used in aerospace applications, right, in aerospace applications in order to make helicopter wings, right, so helicopter wings, and then landing gears, right, and other wings or seats, etc. can be manufactured. Coming to the automobile industry, these two are the most important fields of application. These composite materials find application in these two fields, very important, right. In automobiles, they are used in the manufacturing of body panels, they are used in the manufacturing of shaft, bumpers, gears, right, engine parts, etc. it will be used. So in the field of sailboats, right, they are used in the manufacturing of hulls, and then deck, etc. So in recent days they are used in the manufacturing of bicycles, advanced bicycles or modern bicycles and motorcycles, and at last you can call it as modern cycles and motorcycles. So they are bicycles, right, and at last they are used in consumer goods, in the manufacturing of variety of consumer goods such as laptops, tripods, right, hockey sticks, archery, right, tennis rackets, right, I will write only consumer goods, tennis rackets, right, and then fishing rods, and then golf clubs, in surfboards, in billiards, and in making of helmets and shoes in case of racing sports. So in all those fields, these carbon fiber reinforced polymer composites, carbon based composite materials are used. So the next composite is metal matrix composites. Metal matrix composites, right, in short they are called as MMCs, right, in short they are called as MMCs, metal matrix composites. So in the name itself it is saying that as a composites means they consisting of two distinct components. So because of that reason it also consisting of two distinct components, one is a metal part, the other one is a other material, right. So usually a metal matrix will be reinforced, right, usually metal matrix will be reinforced with other materials in order to make matrix stronger, right. So most metals and alloys form good matrices in this field, right. So MMCs, that is metal matrix composites. So with this introduction, if you can come to the properties, right, they show excellent properties, right. So compared to carbon based fiber materials, right, the first distinct property compared to that carbon based fiber material is they exhibit elevated temperature capabilities, right. They shows elevated, as we are using metal, that's why they show elevated temperature capabilities, and they show high thermal conductivity. Remember, high thermal conductivity, compared to carbon based fibers, right? Elevated temperature capabilities, high thermal conductivity, and third one is low coefficient of thermal expansion, low coefficient of thermal expansion, right? So just like any other composite materials, they also exhibit high strength to weight ratio. You have to remember this word, right? Compared to its weight, they are very high strong, right? High strength to weight ratio, right? So because of that reason, they are highly strong. Stiffness, they exhibit toughness, right? So all other properties, and at last they are going to show excellent creep resistance, resistance to fatigue, and wear resistance, and resistance to corrosion, chemicals, and all other things. So excellent wear resistance, and creep resistance, fatigue resistance, right? Resistance to corrosion. So corrosion cannot say because we are using a metal there, and resistance to chemicals, right? So like that you can list out n number of properties, right? So these are the salient properties of metal matrix composites. And if you come to the applications, so just like carbon based composites, right? So metal matrix composites also, and okay, I forgot to inform that. So here in this field, right, metal matrix composites, what they will do is they have the potential for replacing cast iron. Based on all these properties, these metal matrix composites have the provide an option to replace cast iron and other metals in the manufacturing of engines and turbines, right, and brakes, right? In the manufacturing of engines and brakes in automobiles, we can replace, right? This is one thing. And in the area of matrix, people have already tried out almost all the metals such as aluminum, right, beryllium, right, like titanium, magnesium, iron, nickel, cobalt, and silver. So out of all these combination, the excellent usage, largest usage in the aluminum matrix formation, excellent usage in the field of aluminum matrix formation, right? So with this, now we can move towards application. Just like carbon based materials, they are also applicable in common fields, such as they are applicable in the field of construction, automobile, aerospace applications, in electronics, right, in medical applications, that and all you can list out. So if you can list out some of the things, they can be used in the manufacturing of racing engines, right, manufacturing of racing engines, and they are used in the manufacturing of tank armors, and similarly they are used in automobiles in order to prepare n number of components. They are used in aircraft applications, right? They are used in space systems, right? They are used in the manufacturing of bicycles and motorcycles, similar to that of carbon based fibers, and they are used in the field of electronics, right, as they exhibit high thermal conductivity. They can be used, and at last, so they can be used in the manufacturing of high speed robots, right, high speed robots also. So overall, the major use is in the field of automobiles and aerospace applications, right? So this is all about the metal matrix composites.